Hi, everyone. We know there are two kinds of magnetic poles which are called something like there are two kinds of poles, that is a north pole and a south pole. This is like a positive and negative charge. We also know that there is a kind of a rule that similar poles repel and opposite poles attract each other. That means one north pole repels the other north pole, but one north pole attracts the south pole. But by how much? To find that out, we have a law called something like inverse square law, like a Newton's inverse square law between the to find the force between the masses, like a Coulomb's law to find the force of attraction or repulsion between the two charges. Similarly, between the poles also there is a force of attraction or repulsion, who is directly proportional to product of pole strengths and inversely proportional to square of the distance. By combining all of them, we can write and we can eliminate the proportionality with a constant which is determined basing on experimental observations. Mu naught by 4 pi m1 m2 by r square, where mu naught by 4 pi is a proportionality constant and it is found basing on experimental results. In that, what is this mu naught? Let me explain to you, right? Mu naught is something called something like permeability of vacuum, right? Or if it is mu, it is of another medium. So what is that permeability? It's a measure of nature of the medium, that how good that medium is or how bad that medium is to pass the magnetic field through it, right? So if a medium is conducive for the magnetic field, it will have a high permeability and it will allow the magnetic field through it well. And experimentally it is found that mu naught has a value of 4 pi into 10 power minus 7. So this 4 pi and that 4 pi can cancel and you can get a different formula, I mean different equation like F equal to 10 power minus 7 into pole strength 1 and pole strength 2 by R square. Few things that you need to observe. First of all, these are pole strengths of individual poles, not of magnets. So, each pole is associated with another north pole or a south pole. Poles always exist in pairs, but we are not bothering about that part now. We are here simply assuming that there is one pole of pole strength m1, another pole of pole strength m2. Between them, there is a distance r. Between them, there is a force of attraction or repulsion of this much. So we don't worry that behind this pole there is another pole, behind this pole there is another pole. That's altogether a different aspect. We will talk about that later. Here we are only talking about individual poles. So the value of that mu naught is 4 pi into 10 power minus 7, where mu naught is called as permeability of the medium. We can find what's the unit of that mu naught is, because I know force is measured in terms of Newton. Mu naught I want to calculate. 4 pi is a constant, it won't have any unit. Pole strength has a unit of ampere meter. Another one is also pole strength, though another ampere meter. By distance is meter square. So mu naught has a unit of SI unit of Newton meter square by ampere square meter square, right? So meter square and meter square will cancel. So that has a unit of Newton ampere power of minus 2, right? That's the permeability of that medium, of the vacuum. Of course, if there is medium, the formula will vary slightly. So in any other medium, in any other medium other than vacuum, you won't get mu naught, rather you will get a mu by 4 pi m1 m2 by r square, where that mu is called as permeability of medium. Earlier it is permeability of vacuum or free space. This is permeability of medium. Of course, how medium how good this medium is or how bad this medium is in passing through magnetic field is measured by that value. Now there is a relation between this mu and mu naught. Mu of that medium by mu of the vacuum, their ratio can be called as mu r, that is relative permeability. So in the place of this mu, I can write F can be written like, in the place of mu, mu r and mu naught by 4 pi by just taking this term to that side. M1 M2 by R square. This force is different, so I'm calling it like F dash. Earlier force I have called it like F. So F dash can be written like, this is all the same F itself, mu R into F. This is how I can relate the forces in different mediums between the same magnetic poles. So this is an inverse square law which further simply tells you that force, I'm assuming writing an equation in vacuum, u naught by 4 pi m1 m2 by r square. If somebody say I have changed, if pole strength is reduced to half, m1 dash is m by 2, m1 by 2, m2 dash is m2 by 2, and distance is also reduced by half. What happens to new force? If somebody asks, I can write u naught by 4 pi is not affected in any way. In the place of m1 m1 by 2, in the place of m2 m2 by 2, in the place of r by 2 whole square. So that is m1 m2 by 4 r square by, this is also a 4. This remains cancelled, this gets cancelled. So the value remains same itself, right? This is how the force is going to be affected when there is a change of medium. There will be a lot of other aspects like what happens if there is an angle between them. We will discuss it in the coming part of the next, in the next video itself. Thank you for watching.